this was one of the problems that we didn't get to in class, and I'd like to expose you to yet another example of finding the interval of convergence for a power series. So it was textbook number 23. We're going to use the ratio test to get started. So let's set that up. I'm going to pause it to set it up to keep this video short. Okay, so the ratio test is set up, and then I just wanted to do the algebra here to clean it up. So you got a 3k and a 3k minus 1, so that leaves a 3 on the bottom. And you've got an x to the 2k plus 3, and you've got an x to the 2k plus 1. So what's left there is actually x squared. Okay, there's 2 left over. There's an x and an x, so that's x squared. Let's rewrite the limit. So this becomes the limit as k goes to infinity of x squared over 3. And there's nothing with k there, so this limit is essentially x squared, the absolute value of x squared over 3, which you can drop because you're squaring it. So for this to converge by the ratio test, so for convergence by the ratio test, we've got x squared over 3 must be less than 1. So solving that inequality, you get x has to be less than the square root of 3 and greater than the negative square root of 3. So we need to test the endpoints. So let's go ahead and set that up. Let me grab another color here. So we're going to test the endpoints. Right, because we use the ratio test and R is inconclusive at the endpoints. So let's plug the endpoints into the original series and see what we get. So it's the square root of 3. Plugged into the original series. You get square root of 3 to the 2k plus 1 over 3 to the k minus 1. And I'm going to rewrite the root as an exponent so that I can show you how to apply the 2k plus 1 over 3k to the minus 1. So let's just multiply the exponents, same base, and you're left with 3k plus a half over 3k minus 1. Just a lot of algebra here. Right? And I'm going to rewrite that. I'm going to split out the 3 to the k. So I'm left with 3 to the k times 3 to the 1/2. And down here I'm going to pull out a 3 to the k too, which would mean this is 3 to the minus 1. So I can cross these out. And what I'm left with is the sum of 3 to the 3/2, which, let's use the divergence test in this case. I'm going to use the divergence test. The limit as k goes to infinity of 3 to the 3/2 is equal to 3 to the 3/2, which does not equal 0, so it diverges by the divergence test. Okay, so that endpoint is not included. And likewise, we can show it, for x equal to negative root 3, we have the same sort of argument. You know, you can go through the algebra slightly different, but not a whole lot. Right? You're going to set up your original series. And you're going to have to pull in all of your Chapter 8 tests when you're reviewing the endpoints, when you're examining the endpoints for convergence. So, you may use the alternating series test, you may identify this as a p-series, you may pull in a harmonic or an alternating harmonic. You're going to use all the knowledge that you've accumulated from Chapter 8, which is pretty vast, and apply it to these endpoints. So that's where you're going to be getting creative. Okay, so this is the same sort of thing, except you end up with negative 3 to the square root of 3. And again, this diverges by the divergence test. So your interval of convergence, I, is equal to negative root 3. Sorry about that, I had something on my screen. Negative root 3 to positive root 3. So I would recommend at this point just doing quite a number of problems to get yourself comfortable with this.